Yeah, period of silence then, please, guys.
Hello and welcome once again to the Weather Studio. We are broadcasting live here at the Met Office. I'm Aidan McGivern.
And I'm Alex Deakin. And for the next 20 minutes or so, we'll be talking about all things meteorological from around the world to focusing in on the UK. And it's a really energetic week this week. It's the Northern Hemisphere summer's really starting to get going. So we've got lots of high energy things to talk about. We're talking tornadoes. We're talking tropical cyclones. What else is on the cards, Aidan?
We're talking thunderstorms in the UK. We've got thunderstorms coming up here in the UK over the next few days. So, of course, we'll be talking about how lightning forms, and we have a special guest to explain the processes behind that. And, of course, we'll be giving you a glimpse ahead to the forecast for the long bank holiday weekend.
And maybe even further ahead, because it's half term for many people next week as well. So a look at the weekend and a little bit beyond that as well. But first of all, got some sexy footage to show you. First of all,
Incredible
let's start with the high drama going on here. What's going on here, Aidan?
This is a tornado. Now, we often talk about tornadoes in the USA, but this is in Germany, West Germany, near Dusseldorf, and look at the power of this thing. And you can see the hail bouncing off the pavement as well. An incredible tornado here, and another video from a different angle, a more scary angle, in fact. Someone taking this from their car. Look how close that truck is. Pretty scary if you were...
This was just this week?
This was last Wednesday in West Germany, and it caused fairly extensive damage. It hit several towns in West Germany, a region called North Westphalia, and it was a beast. It ripped off the roofs of 50 homes, damaging them, and it also injured 2 people. Fortunately, no one was killed. But it just goes to show that you don't just get damaging tornadoes in the USA, you can find them closer to home.
It's been quite a slow start to the tornado season in the US, hasn't it?
It has, yeah, the slowest on record in Oklahoma and also in Kansas. And yeah, it's got going now, but of course tornadoes are found throughout the world. Another region where tornadoes are quite common is southern plains of Canada and also around Brazil, Paraguay, Uruguay. But the most deadly part of the world for tornadoes is actually Bangladesh, possibly due to the high concentration of people, but they do get some very violent tornadoes in Bangladesh. One tornado in 1989 killed 1,300 people. But we were talking about tornadoes closer to home.
Yeah, it also peaks this time of year in Bangladesh as well, doesn't it, ahead of the monsoon season. But we do get some in the UK.
We do, yeah. It's often quoted that the UK gets the highest concentration of tornadoes in the world. And this graph shows data from an organisation called Toro. This was a study from the University of Manchester back in 2010. And it basically mapped and graphed the number of tornadoes that were spotted in the UK. Now, of course, we haven't quite got the satellite footage and the radar footage to identify tornadoes from space, so we rely on eyewitness accounts, and Toro has this extensive data stretching back many, many years. This goes 1950 to 2010, showing the number of tornadoes each year, and it's highly variable. I mean, typically it's around, say, 30, 40 tornadoes. It follows this...
Do you know what this blue line is? Is that the average?
That's the rolling average, yeah, over the last 30 years or so.
What's that? Yeah, just around about 50.
That's 47 over the last 30 years. That's the average, but that is highly skewed because, look at that, 1981 and 1982, 150 or more tornadoes. But like I say, these are based on eyewitness accounts, so it might just be the fact that we have more people spotting them in the UK.
If a tornado happens in a forest and no one sees it, does it happen?
Doesn't register on the UK tornadoes
That's a big
graph.
question. Yeah.
That's right.
Okay.
But of course, we could get other data from these eyewitness accounts. This is a map showing the distribution of tornadoes. And actually, it's kind of what you'd expect, which is that you get a higher concentration in the southeast of the country. Because tornadoes in the UK normally form around summertime thunderstorms, and that's the part of the country where we get typically...
You need high energy. You need the energy as well,
exactly.
so the warmth helps it as well. So the warmer conditions in the south are likely to spark more thunderstorms, which can then breed the tornadoes. That's an interesting map. So the most likely region, or the most regular
Tornado Alley, UK's Tornado Alley, runs from, say, around Berkshire up through Cambridgeshire into Norfolk as well. Now, a lot of these tornadoes are relatively small. They're F0 or F1 on the
What's F?
tornado. Well, that's the Fujita scale, so it measures the size and the power of a tornado, and it runs from F0 up to F5. And in the UK,
0, 1 are at the lower end.
Exactly. Yeah. So in the UK, 95% of tornadoes are at that lower end, relatively undamaging tornadoes. But we do get damaging tornadoes. One in the UK, Birmingham, in 2005, of course, caused £40 million worth of damage and also injured 19 people. So, yeah, we do get some powerful beasts in this country, but we also get quite frequent smaller tornadoes that are spotted.
They're very difficult to forecast as well. We don't often we know when the atmosphere is right for them and can give them, but it's almost impossible to say exactly where and when you're going to get a tornado in the UK.
They don't just happen to do with summer thunderstorms; they happen on cold fronts as well. When you get a particularly active cold front, what we call a squally cold front.
You get the wind shear, don't you? You need the wind shear, which is a change of wind direction, a quick change of wind direction, and that helps to spin the tornadoes up.
Do you know what they call tornadoes in the Netherlands?
No, I don't.
Windhoes, which literally translates as a wind hose.
Oh, that's a whole new feature. There's a whole new feature there, what they call different features around the world. While we're on the subject of different features, if you have any suggestions or any questions answered, then please do fire them into us now. We'll try and answer them if you're watching it live, but even if you're not watching this live, you can still send questions in or suggestions, and we'll try and answer them in a later edition of the Weather Studio. So you can put your questions or your feedback, any feedback welcome as well, down below in the comments. Right, let's move on to talk a little bit about the UK weather, because in an interesting period of time at the moment, high pressure dominating. This is the scene at the moment across the UK. We are talking thunderstorms. This is the scene for Wednesday. A lot of low cloud and muck, as we call it, on the east coast, just affecting the eastern coast. So it's quite grey here. We talked about this before, with the sea so cold, the air condenses over it, and particularly in May, it's often a feature of the weather called fret or har in eastern Scotland. It's grey, it's murky on the east coast, and it's rather chilly. But most of the UK bathed in sunshine, and we'll continue to see that through Wednesday. There's this threat, though, notice here, of seeing some heavy showers breaking out later on Wednesday, and more particularly into Thursday. And we're going to see more of these over the next couple of days. We've seen one or two earlier on in the week across the south on Monday, and one or two breaking out Tuesday afternoon, but increasing threat of more thunderstorms breaking out later this week. This is Wednesday night into Thursday, so you may get woken up by a flash of lightning, that kind of thing. But I just wanted to talk a little bit about, because we're getting to that time of year, about how forecasting thunderstorms is quite tricky. And it's all to do with the size, really, and how they're quite hard to pick up by our computer models. So the computer models forecasting the weather are able to say, yes, there's a high chance that there will be a thunderstorm, and that's what these are suggesting here. But they're very specific in where they are, thunderstorms. They're only either a few miles wide or a few tens of miles wide. So they only hit a certain number of places. It's that classic summer scenario where one place gets an absolute downpour and 5 miles away it's completely dry. And that's partly to do with the size, so the computer models can't resolve them. They can't model them exactly where they're going to be. So it's the kind of situation where your weather app isn't going to be giving you a full detail. It's going to say there's the likelihood or the risk of a thundery shower, but each hour it may have a picture of a thunderstorm, but it's not really going to tell you the actual detail, is it, in this kind of scenario?
And of course, as thunderstorms evolve, they impact on the surrounding weather. So if you have a thunderstorm popping up in one town, then it might actually limit the potential for a thunderstorm to form in a nearby town, because you've got the downdraft or the cloud cover cooling things down. So they interact with each other, and you can't always tell until they start forming exactly how those interactions will play out.
I've got a pan of boiling water here, just because this is a good analogy for where thunderstorms are. So we often issue warnings for thunderstorms because they cause problems, a lot of rain in a short space of time. But when we issue a warning, a yellow warning or even an amber warning, it covers a large area. And think of that. Think of this pan of boiling water as the atmosphere in that area. Now, you start off with just a pan of water, you put it on the heat, and it bubbles up. Now, you know that there will be bubbles, and if you think of the bubbles as the thunderstorm, so you know that there will be a thunderstorm somewhere in this pan of water, there will be a bubble developing somewhere, but until you see it, you don't really know where it is. So that's the analogy we tend to use when talking about thunderstorms in the summer, and that's why we have these tricky situations where we're forecasting thunderstorms in an area, one place gets it, another place doesn't. Some people think, oh, the forecast was wrong, but it's just because you can't really get the exact detail until you really see the light of day. So what you can do is, if you download the Met Office app, on there, you can actually follow the radar. So actually on there's the radar, which tells you where it's actually raining now. So that's a good thing about the Met Office app. Not only will you just see the symbols for each town that you're in, but you'll also get the radar, and you can actually check it for yourself and see whether those thunderstorms have developed.
Question just in. George Birmingham wants to know if any of these thunderstorms are expected in Exeter this weekend.
Well, there's the possibility in Exeter this week. We'll get onto the forecast for the rest of this week and into the weekend in just a moment. But there is the potential in the south for some heavy thunderstorms through the rest of this week. Further north, the weather looks actually
one thing we'll notice in Exeter is that it will be more humid this weekend. Last week we had a lot of sunshine, and warm temperatures by day, of course, but we had chilly nights. The air was relatively lacking in humidity. But this weekend, we've got more humid air coming up from the continent. So that, of course, means that it will be stickier at night, but it also increases that risk of thunderstorms.
I had the fan on last night. It was already too warm for me. It's getting tricky
already. Children, isn't it?
Yeah, exactly. Right, thunderstorms, bring lightning. Let's get our expert in, shall we? Let's introduce Jodie. Hello, Jodie. Thank you for coming along today. Jodie Ramsdale, what's your role here in the Met Office?
Well, I work for the Met Office College. Originally, I'm a forecaster by trade, but now I sort of teach the weather.
So we might learn something.
hopefully something at home will too. But I also work a little bit by doing some explainer content as well, that you may see some of our animation explainers
because
online.
You've worked on a couple of videos exploring lightning and different types of lightning, how it's formed.
Yes.
So just briefly, can you describe how lightning comes into being?
Lightning is really just a massive spark between a cloud and a cloud, or a cloud and the ground. And I don't know if you've ever sort of walked across the carpet and got an electric shock when you've touched like a doorknob or something like that. It's kind of the same sort of way where it develops to basically different particles within a cloud just banging together and just building up static electricity, rubbing against each other. So here we've got
what's going on here? Mind out the way.
So we've got here.
I'm sorry.
Let the dog see the rabbit.
Too interesting.
You are.
So obviously we're wanting a really big cloud. We're wanting something called a cumulonimbus storm cloud, really. So we've got lots of different particles in there. We've got smaller ice particles. We've got larger hail. So as they sort of the larger hail will want to sort of sink down towards the bottom of the cloud because all the winds going up within the clouds just can't hold them anymore. So they just fall down towards the bottom. They bump into the smaller ice crystals as they do so. So we start to see a build-up of negative charge along the bottom of the cloud because as these bump into each other, electrons are actually transferred between the two, the hail and the ice particles.
I love this. It's like a giant battery
in a cloud,
isn't it?
So these negative hail bits...
Looks like a bat to me. People will see different things.
How your mind works.
Those magic eye pictures,
It's a whole different episode.
So you'll see that the larger hail not being able to be supported by the updrafts in the cloud gradually just fall towards the bottom of the cloud. So that's where the negative charge actually exists, and the smaller ice crystals, having lost their electrons to the hail, they gain this positive charge and they get taken upwards in the updraft towards the top of the cloud. So effectively forming a big battery
in the middle of a cloud.
Yeah,
right. Okay. Wow.
And of course there's a different charge on the ground as well.
That's it, yeah, because as the charge builds at the base of the cloud, as this gets more negative, it repels the charge on the ground. So it repels the negative charge on the ground. So it ends up with this like positive charge on the ground, and it can be concentrated on. It can be anywhere. The positive charge on the ground can be anywhere, but you'll generally find it's more concentrated on more pointed objects. So we've got things like street lamps and trees, tall buildings,
golf clubs.
Yes, even
golf clubs. You should never play golf in a
people.
Thunderstorm.
Yes,
there's always a big warning.
Experience.
No, not from experience. But they always have horns. I mean, especially in America, because obviously there are massive thunderstorms over there, and they have big golf tournaments, and whenever there's any risk of any thunder nearby, they sound a massive horn, and everyone has to stop playing because they're so dangerous.
Yes, you're not going to want to swing something metal around when there's that risk. No, obviously not. So. So yes, we have this sort of like shadow of positive charge on the ground, and it's only when the charge between the base of the cloud and the ground gets so massive that actually we'll start to see, we have these here called stepped leaders. They gradually work their way down from the base of the cloud to start to try and neutralise that charge separation.
So Describe the stepped nature of this, because it doesn't just go down in one pulse,
No. It's, air itself does not conduct electricity, so it's really quite a difficult process for the actual lightning strike to actually form. It needs to sort of map out a path between the base of the cloud and the ground. And these are like the pioneers, I suppose, mapping out the routes from the base of the cloud. So these are called negative sort of stepped leaders, and there can be quite a few of them coming down from the base of the cloud.
Right.
And it's only when they get fairly close to the surface of the ground that the ground starts to respond to the incoming huge charge that's coming down towards it. So if we see the next one, these red ones here are actually positive or upward streamers. So they're the ones that gradually just sort of like join together. So again, it can be any of these can actually join the step leader, but when they do eventually find someone to connect to, that's where massive charge, massive release from the base of the cloud.
You can see that in slow motion video footage, can't you? You can kind of see the small steps and then boom, the big flash.
Yes, and we're talking hundreds of thousands of miles per hour in terms of how quickly the flash is actually released. Also, there is kind of a difference. We talk maybe sort of lightning flashes, lightning strikes, and actually the lightning flash is what you see, but actually the lightning strike are lots of different strikes within the same path, and that gives you that flickering appearance.
Yeah. Okay. Well, excellent. And the thunder, obviously that's the lightning. But thunder, what causes that?
Well, the path that's taken from the base of the clouds is only a few centimetres wide, but it gets heated to about 30,000 degrees. So we're talking about 5 times the surface of the sun in terms of how hot it actually is. So that heats causes a shockwave within the air. It rapidly heats the air around that path. And that's the thunder that we hear is that shockwave.
So it's the heating of the air around it that makes that, and it's that you get the boom as well.
It sounds like a tear, doesn't it? When you're really close, so it's like someone's tearing the air in half.
That's it, and it's actually our viewers could, if we have any storms later this weekend, they can actually count the difference, because we see the lightning before we hear the thunder, because light travels faster than sound. So they can count. If they see a lightning strike, they can count the difference between seeing the lightning and hearing the thunder. Divide that by 5. That gives you how many miles away it actually is.
Good. So we can do that this weekend, potentially, with some thunderstorms on the way.
Yeah.
And also this weekend, you can watch that whole video. If you go to our Learn About Weather channel, which is another channel we have here on YouTube, there's all kinds of animations on there, all kinds of great videos, which Jodie's been part of as well. So there's all kinds of stuff on there. It's another great resource of weather information. And again, if you've got any comments or suggestions or ideas of other weather videos that we can make, just put them in the comments. Put them in the comments below, and we'll try and do our best to make as much as possible. But thank you very much for coming along.
Thank you very much.
Really interesting, fascinating stuff.
I did learn something.
Yeah, me too. Good stuff. From lightning, we'll move on now to more energetic weather. We're talking about cyclones, tropical cyclones, and in a slightly unusual place. You normally think of them, obviously, the Atlantic season getting underway now, and there's going to be a forecast from NOAA actually this week of their projections for the Atlantic hurricane season. Typhoons in the Pacific, obviously, but in the Indian Ocean we get cyclones, and this is an unusual one. It's quite tricky to work out where we are here on the map, but actually this is the Horn of Africa here, and this is the base of Arabia, if you like, and this is Yemen here, and that's Oman up there. And this cyclone, Sagar, happened earlier on, well, last week actually. Quite reasonably unusual to get a cyclone in this place, but this part of the world, I say every 2 to 5 years Oman gets hit by a cyclone, but the fact that it tracked its way down towards the more southern parts of Yemen is really unusual and creates some flooding in Djibouti over here. So for Djibouti to be affected by a tropical cyclone, really, really unusual. And some of the images here of some of the damage that cyclone did. It wasn't especially powerful in terms of wind strength, but obviously dropping a lot of rain in what is normally a very, very dry part of the world. So it did cause extensive flooding here and caused significant problems in Yemen as well. Did cause some fatalities also. It was quite well forecast, so we were able to flag it up in advance.
We were watching it several days in advance because, of course, different computer models were saying slightly different things in terms of whether it was would be Yemen or whether it would be Somalia or Djibouti who would be impacted most from the rainfall, and these are, of course, very vulnerable parts of the world. So, yeah, we were watching it closely, but it was well forecast.
It was, and yeah, there was a lot of warnings out to fishermen as well about because obviously that's a big part of the industry down there. And it caused some massive impacts. And bizarrely, or quite unusually at least, there's another one now forming. If we spin round to that part of the world and look out again into the Indian Ocean or Arabian Sea, here there is another storm which is forming now, and looks much more intense, this one actually as well. Now at the moment still out to sea, but it is really gradually heading its way northwards and could cause, again, some serious problems in this part of the world. Now, just like the one with last week, there is some uncertainty about the exact track, and before it actually makes landfall across either Oman or Yemen, we're talking another few days yet. But this storm being named probably around about now, actually, by the Indian Meteorological Department look after storms in this part of the world, so they'll be naming it this afternoon. And it is quite a powerful one. It's a more powerful storm, this. It's probably equivalent to Category 3 hurricane in the Atlantic. So it's a pretty big beast, and again, quite unusual in this part of the world to see a storm like this. And it's tracking its way slowly up towards Yemen and Oman. So you can see it's just getting closer and closer.
So a slightly different track compared to the other one.
Yeah, this one looks like it's going to head almost sort of due northwestwards. I'm going to show you now the projections, some of the computer projections in terms of rainfall. So these are 3 different computer models. Again, you can see here on the map, that's Yemen there, and there's Oman, so this is the Arabian Peninsula, and this is the amount of rainfall coming from that storm until the weekend. So it's a cumulative rainfall between now and the weekend. You can see really bright colours here, the purple colours, and the computer models slightly different in their position of the heaviest rainfall. It looks as if it's more southern parts of Oman and the extreme east of Yemen that are going to bear the brunt from these downpours. And we're looking at totals in here, rainfall totals. You probably can't see that on the screen, but over 500 millimetres of rain. The maximum in here is over 1,000 millimetres of rain from this computer model. So there is some uncertainty about the track, but it's going to bring very heavy rain wherever it hits. It will bring significant storm surge as well. That's where the waters get welled up ahead of these storms. And it will bring some strong winds because it's equivalent to a Category 3 storm. So we are expecting serious damage in this part of the world.
Incredible how these rainfall amounts compare to what they normally get.
Yeah,
isn't it?
yeah. So let's look at this is a city, Salalah, which used to be the capital of Oman and is right in the firing line for these storms, pretty much where we're expecting it to make landfall or close to. And these are the stats for Salalah throughout the year. And you can see that in May here, the average amount of rainfall is just 17 millimetres of rain. Now, you've got to take these averages with a pinch of salt because these kind of locations are mostly dry through the year, but they do occasionally get these big events where they get a lot of rain in a short space of time. So it's a bit misleading to talk about averages, but that will be a significant amount of rain compared to the monthly average if that happens, and that could cause some serious problems because Salalah does have a population of over 300,000 and it's very low lying.
Yeah.
So if we get that storm surge, then we're likely to see flooding as well as the wind damage. So it's going to cause some problems. Just another interesting point about Salalah as well. Notice here, you'd think that in July and August be its hottest months, but it's not because you get the southwesterly monsoons here, which introduce a lot more clouds. So the southwesterly monsoons along that coastline of Oman bring quite misty conditions. And you can see here, this is the amount of sunshine. Just to see the amount of sunshine really drops off in July and August as that southwesterly monsoon wind sets up. I just thought I'd bring up the monsoon because obviously it'll be impacting India soon. We'll be talking about that.
We're starting to see the rains begin to ramp up there in the south of India.
But, yeah, a very real threat of some serious problems from that storm. Obviously, we'll be keeping you updated. Now, this is the UK forecast for the next few days, and let's just put the jet stream on because if we focus in back home across the UK, high pressure is going to dominate for the next few days and into the weekend, which usually means fine and sunny weather, and the jet stream's well to the north of the UK as well. As we run through the next few days, we're not going to see a great deal of change.
No, little change. We get our changeable weather typically from the Atlantic, don't we? And the jet stream is taking all that Atlantic weather and pushing it well to the north of the UK. It does leave us with more of a continental influence and more of an influence from the North Sea, so hence the low cloud around those east coasts. and also the influence from continental thunderstorms over Europe. But generally, it's a slow-moving situation with very similar weather.
Here they come. Here are the thunderstorms spreading their way up towards the UK as we go through Wednesday night and Thursday. We talked about them earlier, and there's a greater risk over the next few days of seeing the warmer air pushing northwards, an increasing threat of seeing thunderstorms across southern parts of the UK as we go into Thursday and then Friday as well.
So it's a similar theme for the bank holiday weekend, of course, with high pressure generally centred towards Scandinavia. We've got this influence from the continent. Now, back at the start of spring, we had Scandinavian high pressure and we had the beast from the east. We had the very cold temperatures, but a very different beast now. We've got this continental influence, warm, increasingly humid air, and that risk of thunderstorms, mainly for southern areas.
Yeah, closer to the high pressure across northern Britain. Actually, the weather through Thursday, Friday, and into the weekend, it does look fine. We will still have this low cloud, this mist, this har across eastern Scotland, so there's a chance that some of the beaches here could stay cold and misty. But in the south, it'll be that hit and miss nature of the thunderstorms, and again, the warmth just continuing to build, especially as we go into Friday and into the weekend, the bank holiday weekend as well.
Amazing how this May is turning out, isn't it?
Yeah.
We started spring with such cold and damp weather, and now we've ended up with a May that's been often sunny.
Some parts of the UK have already had more than their May's average monthly sunshine. I saw that on a chart the other day. So some places, up to the 20th, so 2/3 of the way through the month, they've already had more than their average May's average sunshine, and that will continue. We're only going to get more sunshine with this kind of setup. Just notice how this, as we're going now, taking its time, but we're getting into the weekend now, Saturday. Just this warmer air, the warmth, that's the humidity that Aidan talked about earlier. The humidity will be building, and actually, there's probably a greater risk of seeing thunderstorms on Thursday and Friday compared to the weekend. But the similar kind of setup into the weekend and indeed beyond, even into next week.
Yeah, that's right. And of course, bank holiday weekend follows into the half-term week and the rest of May. The signs are that we'll keep similar weather, but there'll be more details, won't there, tomorrow?
There will. What will that be on, Aidan?
Well, I'm looking forward to it because you are presenting the Met Office 10-day trend, our flagship weather broadcast.
Are we calling it that now? That's something we do every week. It's a 10-day trend forecast. We do it every Wednesday. It looks at the weather trends into the weekend and beyond, and the following weekend as well. So we'll be talking about that. We talk a little bit more in depth about the science behind it. We have really great access to the forecasters, the chiefs and the deputy chief forecasters upstairs here in the office. So it's a more in-depth forecast, and it gives ideas for the longer term. So we'll be doing that tomorrow. That will be available on our YouTube channel and on Facebook as well.
An interesting one.
Have we had any more questions?
Yes, we have. Angry in Newton Abbot. Hopefully not angry at us.
Yeah.
Or maybe angry at the weather.
Is it angry or?
It's not spelt. Maybe it is. Maybe it is. She or he asks, how can we forecast an entire hurricane season but struggle to get 7 days right in the UK? Mr. Gree is, of course, referring to the fact that NOAA are releasing their hurricane season forecast on Thursday. And so they're going to be giving an indication of how many hurricanes we can expect, or whether it would be above average or below average, and so on. But that's a very different science to predicting the weather in the UK.
You're using different computer models, more of a climatological outlook at what the bigger weather patterns are around the globe. And they'll only be an estimate. I mean, you know, with the best will in the world, they're not always that accurate. They always give a sort of a certain number of, the most likely number of severe hurricanes plus or minus a certain amount. So they're quite vague. They're for planning, basically, like any longer term
similar
forecast.
to the 10-day trend, where
exactly.
at first we talk about specific details and timings of things, but then as we get into the 10-day range, we talk about trends, warmer or colder than average, that sort of thing.
Great.
So that's to come tomorrow.
Yes.
But that's all from us now. Thank you for watching. If you've got any other questions, you can send them in and we'll try and answer them next week. But we will be here same time next week.
And if you do like what we do, give us a thumbs up on YouTube.
And subscribe,
as well.
Of course.
But, yes, unsubscribe. And we'll see you next week.
Bye-bye.